Well, as always, good morning, good afternoon, or good evening, Algebra Geometry 3 classes. What we're going to look at in section 6.3 will actually follow up with our absolute value inequality notes from section 6.2. You will see a lot of similarities to those, so if you have those pages handy, you might want to refer to those. But the single biggest thing that we are going to look at that's different for today is today we are going to look at the greater than or equal to inequalities. And the biggest difference you can see is when you have either a greater than or equal to, unlike with the less thans where we had an and situation, now we will have an or situation. And we'll actually talk as we look through the first example about what that actually means. So if you look here at example 1, it says we have absolute value of x is greater than 3, means that you are looking for all of the numbers that are more than 3 units away from 0. Again, we've talked that absolute value means the distance from 0. So that would mean you would want all numbers that are greater than 3 or all numbers that are less than negative 3. And we would write that as x is greater than 3 or x is less than negative 3. You know, as far as how that would look with either a number line or your intervals, we'll also talk about that. So, going to put negative 3 and 3 on my number line because they are not equal to. Again, we will use open dots. For the first one that says x is greater than 3, we are going to either shade or draw our arrow to the right. For the one that says x is less than negative 3, our arrow will point to the left. And our interval, this one that's pointing left, will go from negative infinity to negative 3. Again, an open dot means we need a parenthesis. For this one, our open dot, again, will have a parenthesis starting at 3. Going to positive infinity. Now, when you have two separate intervals, we use a U, capital U type symbol. That means the union of the two sets. So, looking now at, some actual examples for it. Question 2 says we have absolute value x plus 7 is greater than or equal to 12. Well, first, we solve as if the absolute value is not there. Or we will have x plus 7 is less than or equal to negative 12. Again, when we have absolute values, you will have two solution sets. One for the positive, you keep the inequality as is. For the negative, you do flip the less or the greater than or equal to a less than. Subtract 7, so one solution will be x is greater than or equal to 5, or subtract 7 and x is less than or equal to negative 19. Again, I'm going to do two things here. I am going to set up our number line. Again, do remember, make sure put the smaller number on the left. Now, because these are less than or equal to, we will use closed dots or closed circles, however you prefer to say it. For the first one, greater than or equal to 5, I will have my arrow point right. Less than or equal to, my arrow will point left. The biggest difference is when you have a greater than to start, your two arrows are pointing away from each other. When you had a less than, the two arrows were pointing inward at each other. So you can see here these are pointing outward. For the other ones, I will even grab a copy. You can see right here, the less thans are interval. Both of the arrows we drew pointing inward. So again, that's the biggest change now. And again, how our interval will look, this one is pointing to the left. That means it's pointing to negative infinity. Stops at negative 19 because of the closed dot. It is a bracket. Anytime you have a gap, we're going to use a union. Our next interval starts at 5, goes to positive infinity. For example, 3 2x minus 9 is greater than 16, or 2x minus 9 is less than negative 16, and we are just going to solve each of those. So add the 9, divide the 2, and x is greater than, you can either leave it as a fraction. If you want to make it a decimal, that's fine. Or add the 9, 2x is less than negative 7, divide, and x is less than negative 3.5. Once again, you can either leave those as fractions, you can write them as decimals. As far as our number line and intervals go, negative 3.5 is on the left, 12.5 is on the right. These are not equal to, so we will use open dots for the greater than 12.5. Our arrow or shading will go to the right. For the less than, it goes to the left. And again, this one pointing left goes to negative infinity. Open dot, we use a parenthesis, and then we'll have our union with our next interval starting at 12.5. Again, open dot, parenthesis, going to positive infinity. So there's our number line, there is our interval, there are your set notation inequality. So just a couple of other examples. Certainly, as we go through these, anytime you are interested in hitting pause, trying one of them on your own, always feel free to do that. Absolute value 3x minus 4 is greater than or equal to 17. Well, once again, I am going to set up my two inequalities. Greater than or equal to 17, less than or equal to negative 17. Add the 4 first. And divide. So here x is greater than or equal to 7. Add the 4. And divide. This one does end up being a decimal. Certainly you can write the point through repeating. If you just round it to negative 4.3, that certainly is fine as well. So here are our two sets. Again, negative 4.3 will go on the left as our smaller value. 7 goes on the right. These are equal to, so we will use closed dots or circles. And then for our shading, greater than or equal to 7 will point right. Less than or equal to negative 4.3 will point left. So negative infinity, negative 4.3. Again, closed dot, I will use a bracket. Union, again, bracket starting at 7 going to positive infinity. Now, the final problem in this group does have a negative, and we're going to talk a little bit about that. If you have something like absolute value is greater than or equal to a negative, well, if we look back at example 5 on our last set of notes, when you have an absolute values make everything positive. An absolute value will never be less than a negative number. Number 5 on this set, though, will not be no solution. When you have an absolute value greater than or equal to a negative, that will always be true. So when it's less than a negative, it's no solution. When it's greater than a negative, that's going to be where your answer is either, I'm sure past teachers have said infinitely many solutions, IMS, all real numbers. So again, I'm going to actually write those out. Infinitely many solutions, or all real numbers. I know depending on who your past teachers are, you may have seen either of these. Now, when there was no solution, we did not need a number line or an interval. If it is infinitely many solutions, we are at least going to have you write an interval. The interval for that solution set is simply negative to positive infinity. That means every number is included. You do not need a number line. That would just be the entire number line. So that is the first section or first part of 6.3. When we do day 2, it will basically just be a summary review of 6.2 and 6.3 day 1. There will be assignments on Schoology for these topics.